Right, so Alexandra, I'm going to go over B, all right, or C. Right, before I go over C, I'm going to go over a similar question. Girls, are we going to listen? Now, what the problem is with this is how does C look different to B? Excellent. So what we need to do is we move the x cubed up. And what happens when we move something from the bottom of the fraction to the top of the fraction? Excellent. It becomes minus. So we do equals 3x minus 3 plus 4x squared. Once you've done that, the differentiation should be easy. So the differentiation involves moving the power in front. So it'd be 3 times minus 3, which is minus 9. Then you make this one smaller, so it becomes minus 3 goes to minus 4. This one's easy, 8x. And that's your answer.
But is that C?
That's a similar example to C.
Okay.
So now you can see that. Can you have a go at C? Is that all right?
Mm-hmm.
Yeah.
Can we do it like I was doing just there?
Yeah, on the board.
Say that again?
Can we do it on the board?
What you want to do on the board?
Yeah.
Yeah, of course.
Oh, es más pequeño. Son 3. Y luego aquí menos 2 por 2 menos 4. ¿No?
Esto,
No,
esto.
2 times minus 2 is minus 4. Ahora ¿quién hace ese? Yo no hago eso.
Square root.
What's the square root as a power?
F4, 3.
No.
What?
If you wrote a square root as a power,
What do you mean?
so a power is like 3, power of 3, a power of 2.
Oh.
So how would you change that to a power? It's going to be a fractional power. So it's the power of a half. So change square root to a power of a half on the next line.
It's yours.
And you can also take it up to the top as well.
So is it? Is it that?
Almost, yeah. You're missing something from your answer.
Minus? Minus?
See,
Oh yeah.
you've moved it up as well. So that's complicated because you have to do two things. You have to put the half and then you have to move it up.
And so what? Okay. ¿Nadie lo quiere hacer?
No.
Vale, ¿y ahora? Entonces, how do we do that now?
Now you need to differentiate it. So like before, you're going to bring the power in front. So what are you going to times together?
3 por menos.
Yeah.
Yo no sé cómo se dice. And so is it?
That's it. And then you're going to take 1 away from the power.
And so?
Yeah, I did that.
Minus half minus 1.
Minus 2.
Yeah.
3
Over.
2.
Yeah.
No sé cómo he hecho eso.
Lovely.
And then, no sé, ayúdame.
¿Dónde estás?
¿Ves? Is it? No?
Okay, I'm going to give you a hint on how to do this. Got everything right so far? First of all, you've forgotten to bring the minus 3 over 2 down.
Oh, yeah.
And then, if you want a minus 1 is the same as doing minus 2 over 2.
Yeah.
So if this is a 2, change this to a 2, so then you combine these together, so that's going to be minus 5 over 2. So the answer is minus 5 over 2.
Okay.
And because this is a plus minus, you can get rid of the plus.
Okay.
Is that all right?
Yeah.
Okay. Right, I'd like to go over this. Please, please, please interrupt me. There's only 3 of you, so if you need any help, let me know. So, differentiation is about maximisation and minimisation. If I drew a picture like this, and this is going to be my curve, why would it be about maximisation and minimisation? Can anyone tell me how this links to the curve itself? Yes, that's right.
Maximum
Maximum, excellent.
and the minimum.
Yes. So the purpose of differentiation is that when you're differentiating, this is the original curve, which we call y. And then when we differentiate it, we get a whole host of, we get one equation, but it can be represented in lots of different ways depending on where it is on the graph. Does that make sense? And this is going to be the differential of the curve. We call this dy by dx. What do we notice at the maximum and the minimum for the particular straight line here? What do we notice about these lines? They're parallel, yeah. What do we notice about their gradient? They don't really have a gradient. So basically what they do is they have a gradient of 0. So whenever you're doing a problem like this, a real life differential problem, normally you have to form an equation based on y, which is the original curve. You will then differentiate the equation, which will give you the line, and the line will change depending on where we are looking at the curve. And to find properties of the maximum or the minimum, we set it equal to 0. Why do you think we're setting the equation equal to 0? Based on the knowledge we talked about with the minimum and the maximum. This equation here is called the gradient function. It will give you the gradient at different points of the graph. If we set it equal to 0, we're going to get a 0 gradient. These two parts are a 0 gradient. Why are they 0 gradient?
They're just a line like this.
Yes. So once we differentiated and set it equal to 0, we can work out where the minimum and maximum is if we solve the equation.
When we set it to 0, it's only to find the maximum and the minimum.
Yes. But these are what the problems are generally about. So the problem is to set up the equation, differentiate it, solve the equation at 0, and that will tell you properties of the minimum and maximum. That is the general steps which I've listed down here.
How do you know if it's the minimum or the maximum?
You use a sign diagram.
Okay.
So can you remember using sign diagrams? We did at the end of the differentiation lesson.
Uh-huh.
And basically, what you need to do is, it's quite complicated, but you study the gradient of this line. So let's say that this maximum occurs at 2, and this minimum occurs at 5. What you're going to do is study to see what happens to this function either side of 2. So what numbers would we select? 1 and 3. It doesn't matter what you select, just something bigger and smaller. And what about the 5?
4 and 6.
Now you don't need to do loads of working out in this in the exam, but what we're going to effectively do is we're going to ask ourselves what happens at 1, what happens at 2, what happens at 3. And this is what we call a sign diagram. So at 2, what is the gradient going to be? 0. At 1, what is the gradient going to be by just visually looking at this?
-1 or at 1, no?
So is this gradient positive or negative?
Positive.
Positive. So we call that positive. At 3, what's the gradient, positive or negative? So if we're generating a maximum, we're going to have a positive, then a 0, then a negative.
Yeah.
That is always the case. So memorize that, or you could draw the exam.
Yeah, so Miss.
Yeah.
We can do that table thing.
Yeah.
When we visually have it.
Yes, you could do it when you visually have it as well.
But when I don't, I can't.
So what you can do, there's 2 ways of doing it. You could visually do it by looking at the graph on your TI-84.
Yeah.
The way I've taught you is by looking at the table. So let's say we have a graph, y equals x cubed. I don't know if this is going to work. X squared plus 4x. The first thing you would do for a maximisation problem is you differentiate it. 3x squared plus 2x plus 4. Often in the exam they'll help you out and they'll say this is the answer you should have got to. So if you can't get to that step, you can still do the other bits. Then, hello.
Hello, how are you?
Good, thank you. How are you?
Yeah, I was searching for the laptop.
Not here.
Okay.
Then, what we're going to do is we then would set that equal to 0. We can either algebraically solve that. We could use the quadratic equation. You quite like using the quadratic equation, don't you? Or you can solve it on your calculator. So on your calculator, you're going to see where it crosses the x-axis. That will give you the two solutions.
But am I not supposed just to change x with 2 if the...
What do you mean x with 2?
Because you said that we put 0 equals 0, like the equation equals 0 when we don't have a gradient, when it's just like, right.
So this differentiated
Yeah.
gives you the gradient of this curvy function
Yeah, exactly.
at any point, but you have to substitute.
X with 2 because the gradient...
Yes, but this is a different, this picture on the left is a different example to this one on the right.
Okay.
But if this did work, yes, the next step you would then do is set it equal to 0, find out what these two special numbers are by working this out on the calculator or algebraically, and then you're going to get your two solutions. And then you're going to examine these two solutions for sign diagrams. This will give you a sign diagram for a maximum. And what's the sign diagram for a minimum going to look like?
Minus 0 plus.
Minus 0 plus. We are actually going to do a proper question in a second because, girls, I do realise this has been a really quick overview. I just wanted to overview it for you before we do this actual exam question. And the reason why this is a quadratic is because the gradient will change quadratically depending on the x value. So as the x value changes, this gradient's clearly going to change.
Yeah, but miss, if you say the equation is equal to 0, there is no gradient. In that case, in the last equation you just
This
wrote,
one.
there's no gradient.
So this tells you the gradient.
Yeah.
When the gradient's equal to 0, we get a horizontal line.
Yeah, so exactly in that case there's no gradient.
So when this equals to 0, we're saying we need to solve for x.
Yeah.
When we solve for x, this will tell us, we're trying to work out how to solve this equation so that this equation will be 0. This will give us two solutions of x, which will then cross the graph, which will then we need to study using these sign diagrams. Shall we do this proper full example? Or you still want me to talk about that a bit more?
I just don't understand. Because you said when it's equal to 0 there is no gradient. So how can we find two values if when we like put it in the equation it's equal to 0, so there's no gradient? Do you understand?
Yeah, I do understand. I'm trying to explain it without confusing you even further. This is called the gradient function. When we take the gradient function and we set the gradient function equal to 0, this is going to generate one or two different values of x's, which will tell us that the situation when this gradient function can be equal to 0. In terms of a graph, this is a separate graph to this graph. I don't know whether to carry on with this example with you or whether to do a proper example because I feel like
Yeah, we can do the proper
because I feel like I've bodged this up a bit because I don't know if it works and it's a bit complicated. I prefer to do a proper example with you and then you're going to understand. This was supposed to be a quick overview.
Yeah.
Is that all right?
Yeah, it's okay.
Alexandra and Aurelie, how are we feeling? Okay. I think the one thing you should write down if you're not sure about any of this is the fact of sign diagrams. And the first one is a maximum plus a 0 negative, and the second one is going to be a minimum. That's the key thing you need to have got from my really long description, plus just the overview of what we need to do. So hopefully this explanation will help you. Have you written down that's a maximum and that's a minimum?
Yeah, I'm sure about everything, just the 0 thing.
Just the 0 thing, great. I'm happy to go over that question with you now then. I rub everything off then?
Sorry?
Can I rub everything off?
Yeah.
Right, Alexandra and Aurelie, please ask me questions as well. I want to make sure you all understand. But remember, if you don't get the whole question right in the exam, you can get marks for sections of it. So, like this part, this is still quite important to be able to know how to do this. There's going to be opportunities where we can do it on the calculator or do it manually. Would you prefer to do it on the calculator or manually? Or both? Both, okay, because I know you're all quite good at both. Now, this question, I'm going to say it starts off out, I think, as one of the hardest questions on the paper too. And the reason why I find it one of the hardest questions is because it was one of the only questions in the paper where I actually had to sit down for 3 or 4 minutes to actually get started with it. So if you're struggling with this, don't worry. What I think is specifically difficult is question A. And these past papers have been released by IB, and we're speaking to Mr. Kearney about them, and we think they're really quite difficult papers. We're hoping they're not going to be as difficult as these 2 papers, because I don't think that there's any really nice questions. But we don't know, so let's prepare ourselves for this. Now, A is the hardest part. B to E, I think, are relatively easy. But what's hard about this question is that A will throw you off. But don't worry, because you can carry on with the rest of the question without doing A. You have to read it really carefully. A box of chocolates is to have a ribbon tied around it as shown in the diagram. Has anyone done this question?
I think I did.
The box is in the shape of a cuboid with a height of 3 centimetres. The length and the width of the box are X and Y. Now, does anyone, this is the bit I struggled on, want to come up and try and label 3 X and Y for me? Do you want to have a go? What do you want to tell me?
Yeah, so 3
Yeah.
is, well, that one, that's
X.
the long one is X.
Excellent. Why is that X?
Because the length,
Yeah.
that's the length.
It's X. Well done. So we've done that one. I'm going to tick that one off. Now we need to add Y and 3 to the box.
Y is from there to that short, yeah.
Yeah, well done.
That's Y.
Excellent. So we've got 2 dimensions of cuboid, and the final thing we need to do
And 3 is the length, and it's up to down.
is the height.
Yeah.
Now, the reason why I struggled with this is because I just randomly labelled them X, Y, and 3, which would be fine for most cuboid questions, but this is very specific about the ribbon. So this is why you've got to label it carefully. So the first thing we need to do is find the total length of the ribbon L. Now, it says for the ribbon L, it wraps around, maybe I'm not good at this question because I'm not very good at wrapping presents. You've got to go around the box once this way, and then the box once this way, and then what else have we got to add on? Can you see in the question what else we've got to add on? An extra 10. So at the end, we're just going to write add 10. So this is the way I think about it. First of all, I'm going to do this dotted ribbon. We can only see half of that dotted ribbon because it goes around the other side as well. So this is going to be this dotted height. What's that going to be, Aurelie? What's that height?
Same as 3.
3, well done. I'm not very visual, so I have to really think slowly about this. Then this one here, Gwendolyn?
That's
Y.
Y.
And because we're doing this twice to go around the box, we're going to do 3 plus Y plus 3 plus Y. That is our first section. Do we understand that so far? And I think all of you will actually be better at this question than me. Then, because you're all very logical and you're very clear with your workings out, not rushing through your questions. Now we're going to do the ribbon going the other way. So we're going to do this lined bit. So this is going to be the dotted bit. How are we going to do this lined bit going this way? This vertical height. 3, yeah. And then going across here. X, and then we're going to repeat it again, plus 3 plus X, and then we need to add the 10 on. Why are we adding 10?
Because it says.
Why are we adding 10?
Because it says so.
Says so, well done. And then we just simplify. So what we're going to have is 3, 6, 9, 12, 22, 22 plus 2y plus 2x. Now, for some reason, I found that really difficult to do. So I don't know why I found that really difficult to do. That's quite easy now I've explained it, isn't it?
Is that for A?
That is for A. What I actually found difficult was B, sorry. A and B, if you can't do A, you can't really do B. That's the difficult part of it. So now we're going to have a go at B. Before B, it gives us an extra fact, and they do this a lot in the exam. They give the fact above the question. The volume of the box is 450 centimetre cubed. So that's told me I need to form another equation. Really, it should say form an equation using this fact. So how would we form an equation using the x, y, the 3 and the 450? 3 plus 3. Have I done my maths wrong? 3 plus 3 plus 10. Yeah, thank you. So we're going to have 450. What is the equation for the volume of a cuboid? This is prior knowledge, but this is also on the formula booklet. How would I find the volume of a cuboid? If I had a cuboid like this and it was 1, 2, 3, how would I find that volume?
1 times
Yeah.
3
Yeah. Times
2.
2. So how are we going to find the volume of this shape? X.
Times y times 3.
Yeah, so for part B, we're going to write down 3 times x times y is equal to 450. Now this is where it gets hard and quite mean, this question. What we want to do is combine this part of the equation with this part of the equation. And we want to create this equation. Now I think this is really quite difficult algebra, and I really hope they don't give this to you in the exam. But they might do. Has anyone got an idea how we are going to use these two equations in conjunction to get this equation?
I think, can we do the double equation thing?
The double equation thing. What do you mean by a double? The simultaneous equations?
Yeah.
Yeah, it is a sort of simultaneous equation, but you can't do it on the calculator really because it's too hard to do on the calculator. So it's a manual simultaneous equation. Yeah. Now with a simultaneous equation, we normally want to separate the letters out from each other, the x's and the y's. This equation is written in totally in terms of x's. So we want to get rid of the y. How are we going to get rid of the y? This is the most challenging part of the question.
Is it like, do we have to do it using the other equation, the L equals 22? Do we have to use that one to
Yeah.
get rid of the y?
Yeah. So what I would see is which equation is most similar to this one. Well, that one's most similar. The only thing that's not similar about it is that it's got a y in it.
That's why I was saying the double equation thing, because we can say, for example, y is equal to 450 divided by 4.
Yay! Well done. I just wanted you to say it without me saying it,
Oh, okay.
because I want you to show that you can do it. That's it. So we want to get the y on its own. So we're going to have y equals 450 divided by 3x. And then, what are we going to do with this y? I'll give you a couple of minutes. Let me know when you want me to carry on. Okay. The idea with this equation is, for differentiation, you need to set up an equation where it's just to do with one variable on this side. This is all to do with x's. Now, when we start off with the equation for the length, it's to do with x's and y's, and that's not good for differentiation. So we need to get rid of one of the variables, so it's just in terms of x's. This is just in terms of x's. So we're going to get rid of the y. Because we know another formula about the relationship between the x and y, we know that the volume, which is 3 times x times y, is 450. Instead of writing y in this equation, we can write y in terms of 450 divided by 3x. So wherever there's a y, we're going to replace it with 450 divided by 3x. This is really quite a difficult question.
I don't
Alexandra's got it, Orly hasn't got it.
So it would be L equals 22 plus 2.
Yeah.
In brackets 450 divided by 3x.
Excellent.
But why is it divided by 3x?
Because this equation on the left here is 3xy equals 450. We want to get the y on its own, so we're going to do the changing subject of the formula. So we're going to isolate the y on its own. The y wants to be on its own. It wants to be lonely. It doesn't want to have any friends next to it. It wants everything else to get away from it. So we're going to move the 3x. And what's the opposite of timesing by 3x? Dividing. So what happens is that the 3x, it goes from the left-hand side, and when it goes onto the right-hand side, it goes onto the denominator, which is divide. So y equals 450 divided by 3x.
Oh, so what, like, so 450 divided by 3x is basically just what y is?
Yes! Yay!
Okay.
Does that make
And
sense?
you just put where y is in the L equals, you just put that.
Yeah, well done. But if you don't get this in the exam, it's only 3 marks. It's so much work for 3 marks,
Where
isn't
did
it?
you get the LXY equals 450 from?
3xy equals 450 because the volume of the box is 450.
Yeah, but where did you get 3xy?
Because the equation for the volume is expecting you to then write down that equation.
The LW.
Yeah.
Okay.
It's a horrible question. This B is horrible. And I would probably not do this in the exam. I'd probably skip it out. So then we take this star and we're going to put the star into the dot. So it is a simultaneous equation, but you have to do it manually. And like I said, most people in the class, other than you three, I don't think they'd be able to do this because they're not very good at manual simultaneous equations. And then what you need to do is expand that out. So you'd get 22 plus 900 over 3x plus 2x. Then you do 900 divided by 3, which is 300. 22 plus 300 over x plus 2x. Check it's the same. It is. That's a lot of work, isn't it? You get it, don't you?
Yeah.
Yeah. Does Aurelie get it though?
Yeah, wait, so,
She does get it, does she?
yeah. Wait, so you did 22, and you put 900, you did 2 times,
2 times
right?
450 is 900. Keep the 3x the same, copy the 2x down. 900 divided by 3 is 300. That equation's the same as this equation.
Okay.
Now, the rest of it's quite easy, and you're going to see why it's quite easy. The next step is to differentiate it. So the way we differentiate it is like we just did in the starter. So we're going to have 22, and this x would become x to the power of minus 1, like we did in the starter. Can you remember that? So if you weren't sure of any of this question, just go straight to this part where it says differentiate, and that will give you 2. This will give you 3 marks. See, I think this is a really generous 3 marks. That took me 10 seconds, and that's given me 3 marks.
Yes, when you have a number alone, are you supposed to not write it? Wasn't it
Yeah,
0?
thank you. Second,
Yeah. And why is it minus 300?
because it's a minus 1.
Oh, yeah.
Yeah. Now, D can be done algebraically on the or on the calculator. I think because of the working out on the board, I should do it algebraically first and then on the calculator. Am I able to rub that off in a few minutes? Yeah. So, do you want me to show you algebraically first?
Yeah.
So effectively, with differentiation, whether you understand it or not, to find the maximum or minimum, you differentiate the original thing, and now it's asking us, the reason why it's a maximisation problem is it's saying, can we find the minimum length of ribbon required? What's the minimum for this problem to make sense? So, once we differentiated, we set it equal to 0. So we're going to set this equation equal to 0. Now, in order to solve this, you have to be pretty good at indices, which I'm not sure if you are or not. So we put that equal to 0, and I'll show you how to do it on the calculator in a moment. When we put it equal to 0, I'm going to manipulate it. Now, if it's to a power of a negative power, we want to change it back to the fractional format, because that's not very good to solve. How do I change that back to the fractional format?
-300 over
Yeah.
x squared.
Excellent. Then, another thing I don't like about this question is the fact that we've got our x squared is negative. So how do we make that positive? Change side. So that's going to go from here to here. So then this is going to be 200 equals 300 divided by x squared. Now the next thing I don't like about it is it's on the denominator. How do we get rid of the x squared being on the denominator? It goes up, so it's going to be, it won't be negative. Basically this is divided by x squared, so we're going to move it up here, and then it will become
2x squared.
times by x squared, so 2x squared equals 300. Then we can almost solve it. So we're going to divide by 2, so 300 divided by 2 is 150, and then we're going to find the square root of 150, and that will give us the answer.
The answer of what?
What did you say?
The answer of the minimum.
So, because this question is to do with an x squared, that means the differential function, I'm just going to try and get this right. The differential function is either going to have a minimum or maximum, and this specific one is just going to have a minimum. And the reason why is because the gradient function itself is going to look like this, or something like that. If the gradient function was like this, it could have a minimum or a maximum. But this one just has a minimum. Would you like me to show you how to do part D on the calculator? Or are you happy with that method?